Welcome. So this is a course that has been planned already for quite some time, for 2 years or 3 years with the NIT Warangal, but because of COVID, it didn't take place. And now it is a joint effort. Everybody has seen, I believe, you can see my screen sharing here, right? So so it's a joint effort from a number of institutions. Last year, I was invited to give this course at the university, Saarland University, and I'm right now here in Saarbrücken at
18,
the
19, 20. Okay, 10.
hello. At the, yeah, so this is one organizer. Another one is the Institute of Technology in Warangal, where we have a couple of Indian participants. Then Kent State University, where I'm affiliated, and then this Interact network. That is, I think, a Belgium initiative to for interdisciplinary research in language contact. Here is the website. And yeah, so they were also interested in disseminating this kind of activities. So it's about empirical translation process research, and the idea of empirical translation process research is to figure out what happens in the translator's mind. It has perhaps a history of something like 40 years, starting with think aloud protocols, and then later getting more fancy technological devices to log and to investigate the activities of translators, and then to analyze this and to draw conclusions about effort and difficulties, translation difficulties, and so on. So we have here a couple of resources. The CRITT has developed a couple of resources and a database, and the course will mainly address those kinds of resources. Can we record this data that is produced by translators? How can we store it, analyze it, and what kind of conclusions one can draw? Yeah, so this course does not require very sophisticated programming skills, but a little knowledge would be very helpful. And here are links, suggestions for links, but of course you can use any kind of tools that there is available. So this is one thing, and then there's another thing that we have a Jupyter account. So everybody can open an account, or say not open an account, but use a Jupyter notebook. And I saw that a couple of people have already gone through these steps here, but I'm not sure whether everybody did and whether anyone faced problems in doing so. I will come back to this here after some time, after I go through first through the course and what I was thinking to cover in this course. So, but basically the idea is that we can open here a Jupyter notebook and everybody uses the same user. So this is a user and there's an account, and we all use the same user, because I cannot create for this amount of people different accounts. So we all need to share one account, and how we can open this and use it so that we can so that everybody does not mingle into the data of the others ones. We can look into this a little bit later. And then there is this TPR-DB account, which is different from this account. So this Jupyter account is something where we can run scripts and open the database and do some analysis and so on. And this account here is another account where we can upload data and upload data and visualize this and so on. And there is a different user and name and password and so on. I'm not sure how many people have used this. but if we have time, we can also look into this a little bit later today. So I would like to go through these through this program here for the next half hour or so, and try to explain what I was thinking that this course could be about. So I guess some of you already have downloaded and looked into this. Yeah, and then this is the introductory session here. Then the green ones are sessions where we can look into data acquisition tools. So we have a couple of two different data acquisition tools. Tomorrow, we will look into this Translog-II and see how that works. And then we have another tool, Trados, on the 23rd, and we have the visualization tools and so on. The red part is then where we can look into the actual data and how to analyze and process the data. And the blue one is a little bit looking into the future maybe, and some talks and about experimental design if there's a wish to talk about this. And then we have also spoken data. So, but anyway, so the green part. So tomorrow, we will look into Translog-II. Translog-II is a research tool that captures keystroke data and gaze data. Translation process research has started 40 years ago, and around 95, Arndt Lücke-Jacobsen and his son developed this program Translog, which the idea was to record keystrokes from translators as they type. By then, most translators would not use anymore a pencil and paper, but they would produce translations in a screen, so typing in an editor. And then one could have key logging devices. That is a small program that runs in the background and that logs in time each keystroke or mouse activity. And then one would have one would register and record this, and then one would have a log of how the text evolves in time. And the idea was that if there is fluent typing, that would be an indicator that there is no big problems, that translators proceed smoothly. If there are longer breaks or longer pauses, that would indicate that translators need to think about get some background knowledge, maybe, or do some research or some thinking and so on. And so that was the idea with Translog, to figure out in a way objectively where the problems in the translation process are. Then in 2005, there was another, this eye tracking technology was sufficiently developed, and one could attach an eye tracker to this logging device, to Translog, and that would then give the possibility to figure out where on the screen a translator is looking. So basically, Translog has two windows, one window in which a source text is shown and another editor window in which the translator would type the text. And so the keystrokes would be recorded in time, and the eye tracker would then record where on the screen the translator is looking, and whether they look on the source and the target, or the target side, which segment they would look at. And then also there was something called gaze to word mapping, where the gaze points of the eye tracker would be mapped onto the words, so that we not only know which XY positions on the screen a translator looks at, but more interestingly, which words they were actually reading. And then from there, one could see whether the translator reads forward and how many words they read ahead, how many sentences, whether they make regressions, they reread one sentence a couple of times, whether they would read the source text or the target text, and so on. And from all these different kinds of patterns, it would be possible to assess what the problems are. So, for instance, if a segment or a word is very often read, then or reread, or a passage is often reread, then it would indicate that this passage is maybe difficult to understand or to integrate into the context and so on. So with this data, with this eye tracking data, one would get an impression of how difficult it is to read the text, and then we have the keystrokes at the output, and so then one would have the coordination between reading and typing behavior, and one could compute something, for instance, like um, an IT span. So what is the lag of time between reading a source text word and typing out the translation of that source text word? Um, and so this kind of further measures and analysis of the data could then be used to assess where translators get stuck, where the problems are, and so on. Yeah, so this data would be recorded with Translog, and Translog underwent a number of changes over these, how many, 25 years now. And for the moment, the version is Translog-II, that is stable more or less for the past 10 years, has not much developed in the past 10 years. And this Translog-II, we will look into this tomorrow. Yusheng, if he is there right now, I don't know, will give us a demonstration, because I don't have an eye tracker here in Saarbrücken. So he will do this demonstration from remote, from Kent, I hope, where we can see with an eye tracker, where we can connect Translog with an eye tracker, and we can look into this data and how that is, how the experiments are set up and so on. So then this data would be produced from Translog. I would suggest that everybody can then use this Translog program and run it. So it's free, so it runs on Windows. It can be downloaded from the website that I have indicated. It's on the CRITT website, the pointer. You can download this program from there. It's an MSI program that installs this Translog, and then you can run this Translog and produce some experiments and try to figure out a little bit how that works. And then you gather data, you produce data, an XML file, and this file can then be uploaded to a website, to this TPR-DB, to this Translation Process Research database. And this is then basically the main part of this whole analysis, looking into this database and looking into how this data is represented and how data can be added and modified and so on. And that's what we will do then in these during these red sessions and so on. But so there is so this data can be uploaded to this TPR-DB, and there is immediately some kind of semi-automatic processing of this data. So extracting the process data and the product data. Right. So when a translator produces a translation, of course, the idea the idea is to produce a translation, the translation product, right? So that's the product. So we have the source text and the target text. That is the yeah, so this is textual data, and then we have behavioral data, means basically keystrokes and gaze data. If we have collected also, if we have an eye tracker, we have keystrokes and gaze data, that would be behavioral data, and we can then relate these behavioral and so the process data and the product data. And this will become very clear in the next couple of sessions, how that works and how we can proceed this. And this is done, this linkage of process and product data is done semi-automatically when uploading the data through this browser interface to the TPR-DB, and that was, I believe, one of those questions that came up right now. Everybody has to produce an account like this. No, we just use one account, but we can upload different kinds of sessions there and then look into how this looks like, how this is processed, and so on. So the possibility is there. So this would be, we have two parts at least: data acquisition, and we have different tools, Translog, to acquire this data. So how does the translator actually produce the text? And then we have this database where the data is stored, and we can look into this data and analyze this in various ways and visualize this. And there is here on the 22nd of May, we will look into various or some visualizations of this database. We can replay the sequences of keystrokes, so how the translation emerges in time. One can do this. But there's also different ways of how to visualize this data in a browser tool in a more static way, so that one can see the relation between the process and the product data, which we call translation progression graphs. And here in this tool that we will discuss on 22nd, one can then do some kind of error annotations. So for instance, an interesting question could be, what is the relation between uh, production time and errors? So word translators um, uh, um, uh, need longer time if the output has errors. So we need to annotate the errors in the product and then correlate and see how this relates to the behavioral data. And indeed, one can see we have done this a couple of times, and one can see that if the error is there are translation errors, for instance, accuracy errors, and then often it is an output of the translator then several times revises these parts, and still errors are there, and it takes longer for a translator to produce a part, and still the errors are higher than in those parts that are unproblematic and quite straightforward. So one can visualize this data in a browser tool that we are going to look into on the 22nd of May. And then we recently we have used or extended Trados with these similar possibilities. So Trados, I hope that most people would be aware what this is it? So Trados is a translation memory that I guess almost every translator would know and would have worked with. So translation memories are tools that have a large database of available translations, and they would then just suggest a possible translation for a new translation, and which is very efficient. So it takes so it um, it makes the translation job more productive. And the Trados tool is a very famous. It has perhaps 80 or so % of the market share, at least a couple of years ago. I don't know whether this has changed. It's a private company. It's quite expensive, but since many people work with many translators work with this tool, we thought that it's a good idea to have an interface um, with this tool to record keystrokes and gaze data that are produced in Trados, which professional translators use, so as to have some more realistic assessment of the translation process. Translog here is more a research tool that has a kind of an artificial interface. It does not have grammar checking and all these fancy stuff. Um, no terminology suggestions, no interface with machine translation, all this. So, but all this is in Trados. It's there, so translators can use their usual translation environment. And then Trados has something that is called Qualitativity, which is a plugin to record the keystrokes in Trados. So we can get the keystrokes that are produced from translators when working with Trados. And these keystrokes or these log files can then be converted so as become compatible with the translog format and this TPR-DB. In addition, we can also have an eye tracker connected to it so that we can have almost similar data that we gathered in Translog-II, but only here in Trados acquired through a more professional tool. But this is quite new. Not so many experiments we have done with this. We're starting doing experiments with this. And this will be, there will be a demonstration of this tool on the 23rd of May. And the idea is that Longhui will be doing this. She is in China right now, and I hope things will turn out nicely to show how we can do this, how we can run Trados, and gather the keystrokes and then upload those to the same database. So then on the 24th, there is still something else. So I was already talking about this YAWAT tool. So this YAWAT can be used for doing alignment, but also for using arrow annotations, for instance, based on the MQM, multi-dimensional quality metrics, or other ways. So we want to introduce this a little bit. And how to, we can briefly discuss how to design and implement an annotation taxonomy. So there's very many different ways of what you consider to be an error and how you want to classify these errors and how you want to annotate these errors and all this. So this YAWAT tool gives a small, not very sophisticated, but a couple of possibilities to annotate this data in different ways. And then these annotations can then be added to this database. They are inserted into this database, and then they can be correlated with behavioral data, as I mentioned before. Okay, so this is more or less all about tools and how we acquire data, means the process data itself, so how we acquire the data from a translator when they are working, how we can acquire additional annotations of the data, for instance, segment the text into and align the text, the segments and between the source and the target translations, and annotate errors or whatever else you would like to annotate. You could also, for instance, annotate types of metaphors, or another kind of annotation on the textual level. So all these tools, these are kinds of tools. And then this red part would then look into how
Michael,
we
can I interrupt you here?
Please.
I have a question about the tools. I don't have a Windows PC. Would I still be able to follow along the exercises?
Sure, but then you would not be able to record this yourself. What do you have? You have what? You have a Mac, I then
A Mac,
assume.
yes. Yeah.
There is a Windows simulation on Mac, but I'm not very sure whether this works. Do you use this Windows simulation on a Mac?
I've tried it and it was not very straightforward, so I'm not actively using it. Yeah.
Okay. Yeah, but I guess it should work if you only record keystrokes with Translog. Okay, so then this red part here, the idea is that we look into this TPR-DB. So the green part then talks about how we acquire data, and this red part, how we can access and analyze the data. And as I have already mentioned this, when you upload the data to this TPR-DB, it will already semi-automatically process the data and put this into a couple into number of tables that we will look into quite extensively in this session here, where you can look into the data from different angles. And two obvious angles are the process data and the product data. So for instance, you can look into the product data from a source text point of view. So we can look into each token in the source text and then have different features that describe that characterize what happens to this source text token during the process of translation. So how many, so first thing is, what is the translation actually of this source token, so that we have a correlation between, or an equivalence between a source word or source expression and a target language expression. But then we also have all this data that tells us how this target language expression actually emerged. How many fixations were there on the source side? How many fixations were on the target words? How many keystrokes were produced? How many insertions and deletions were there? So many. How many revisions were there for a word, and so on. So these are then the kinds of tables. From a source point of view, one can also look from the target side, the other way around, or we can also look from the process angle and see, for instance, where do translators stop translating? So what pieces of text are produced very fluently or quite fluently, and where do we have pauses, right? So then we look from the temporal side. So we look at at the timestamps and or at an interval, and try and then we can see what happens during the intervals, the time intervals. So this would be two different kinds of angles in which we can look into this data. And there's in this TPR-DB, there's 11, I think, different tables that look into this data from different points of view. That does not mean there's other ways one could look into this data. But these 11 different tables are already quite a lot, and each of those tables has many features. So so the data is quite exhaustively described in many different ways. And in this red part here, we will look into, we can download this data directly from this database, and we have some kind of routines that can pick out subsets of the data and do some analysis with this. So for instance, the obvious thing first could be a correlation. For instance, a correlation of how many keystrokes there are and how much time it took for a translator to produce the text. And then I wanted to talk here about linear regressions on a segment level, and look into so we can have various independent variables that impact a dependent variable. Can look into this, and then kinds of visualization, how we can visualize this stuff in Python. And then on the 29th of May, we will look into something called word translation entropy. And the idea is here, so basically what this research, what we often do, or usually we do, we look into the variation in translation production. So means if we set up an experiment with Translog or even also with Trados, means that there is one text or maybe two or three, four texts, limited number of texts that are chosen with some criteria. For instance, one text that is easy to translate, another text that is difficult to translate, or maybe one technical text and one financial text and so on. And then maybe we have different participants, so more experienced translators and less experienced translators. And then a whole bunch of those, 10 or 20 maybe, translators, and they translate all the same texts. And then, so each of those translators will then produce most likely different translations. So there will be a slight variation in the translation. Means the source text is always the same, but the output, the translation, will have slight variation in word choice, for instance, or maybe they will have different different structures, syntactic structures, and so on. So there will be a variation in the product, but there's also variation in the process. So some translators might want to read first the entire text, others go immediately ahead. Some do lots of revisions, some think longer and do less revisions. So we have a variation in the product and in the process, right? And this is then the idea is that maybe we can find some reasons in why we can observe this variation. So maybe there is a different kind of variation in the experts as compared to novice translators. So maybe novice translators struggle more with some um, features than expert translators, or even the other way around. Um, or we can see that there is variation for if there is more word choice. So for instance, we can see that some words translators produce a large variation of different solutions. So but for other words, it's quite forward. There's not so many ways how to say the same thing in the target language, so we don't see much variation, right? So if we have an alignment on a word level or on a fine-grained level, we can then see what is the variation, what translation solutions do translators actually produce, and we can see whether all translators produce more or less the same word, the same translation, or whether they pick very different kinds of options and they render these segments very differently. And from this variation, we can compute an entropy measure, so which just is an indicator of the variation, basically, of the word translation. So that's why it's called word translation entropy. So it looks into the translation of a word and measures the entropy, so the variation of that um, of those translation solutions. And this measure has been proven, has been shown to be quite interesting and quite predictive. So means that if there is more variation, means if there is more choices, if there are more possibilities to say the same thing in the target language, then translators often struggle with this or often need more time. So it's an indicator. So maybe they struggle more to pick from those different options the one that they prefer. Right. So this word translation entropy is an interesting measure, and Yusheng was friendly enough to explain this and how we compute this word translation entropy measure in the data. And we can then also link this to linear regression and show that this word translation entropy is a kind of predictive um, um, metric for quite a few different other measures, for instance, for behavioral data. And then, well, what all this boils down to, I think, is relations between effort and effect. So I think what this translation process research very much does is to investigate the effort. In what consists effort? What is difficult for translators? Where do they spend effort, and so on? And maybe some of you know that Krings had this distinction between 3 different kinds of efforts, which is temporal, technical, and cognitive effort. And of course, temporal effort would just perhaps be the duration, how long it takes to produce a translation. The technical effort would then be the keystrokes perhaps produced, or mouse clicks, maybe the how often you look into a resource, an external resource, what kind of research is done to find the translation of a word. So that would be an effort measure. And the effect, I believe we might have interesting discussions what this could be, what the effects of translation could be. But here we can maybe say that the translation itself is the effect, right? And we can measure the effect of a translation by the translation quality. So we can rank the effects and the effort. But yeah, so so basically what all this I think boils down to is somehow conceptualizing what effort means in the translation context and what the effects are, and to find some kind of trade-off between effort and effect that makes a translation reasonable or effective for a translator, and also for the customer, and or for all people involved. Okay, but anyway, so we can look into these effort measures on a segment level. So some measures have been suggested. This would be word pause to word ratio, for instance. How many pauses are there, and for on average for each word that is produced. So kind of my idea what we could look into the data, and look into Python scripts, and analyze the data, and see how we can get the um, important data from this database, and how we can run these Python scripts to generate those measurements, and how to visualize this in different kinds of plots, so scatter plots, histograms, whatever. So on this 1st of June, I was thinking we can talk about spoken data. Also, all this stuff here, Translog and Trados, records only written data. So this is yeah. So how translators use a keyboard to produce translations, or how they post edit machine translation, and so on. But increasingly, I think it becomes interesting also spoken data, and there's increasingly research on spoken data using also similar methods here. And we have developed such an approach a couple of years ago to how to add or how to process spoken data with a translation process research database. Processing spoken data is much more complicated than processing written text, right? So we have with a keyboard, we can directly log this, and we can measure the duration it takes for a word and all this. And for spoken translation, for spoken language, it's much more difficult, because we need a well, we can transcribe this spoken signal, of course, manually, or one can use a speech recognition system. But then to have a timestamp to see how long it takes, one would need to have for each word, one would need to know in time when each word was produced. But this is not usually the case. So usually speech recognition systems would not tell you how long it took for the translator or for the speaker to produce this word or the segment. And they would not also produce this data on a word level. So they would not, so they can transcribe maybe words quite accurately, but they would not indicate how much time it took for each word. So they would not attach a timestamp to every word. And so there was one tool that would do this. This was Watson. I don't know whether this still exists, but based on this tool, we implemented a way to transcribe the spoken data into a word, with a timestamp also attached to it, and then we could add this to the translation process database, and then we can compute something called an ear voice distance. So that would be in the interpretation situation. An interpretation situation is when an interpreter hears a source text, listens to it, and speaks out the translation at real time, so a couple of seconds. So they hear simultaneously at a source text and speak out the translation a couple of seconds after they hear it. So there is something that one can call the ear voice span. So that would be the lag of time between hearing a word, a source text word, and speaking out the translation of that source text word, and how many seconds are between these two events. So that would be an ear voice span. And then we have something called side translation. And this is a situation where a translator reads a text and speaks out the translation. And this situation is sometimes I think used in court when somebody comes with a document in a different language and the translator then needs to read out this document in the language that the judge would understand. And then they read the source text and speak out the translation. So we have something like an eye voice distance where that would be when was the word read. So this is very similar to what we have in Translog. So in Translog, we have an eye tracker and we know when a translator is reading a word. And here inside translation, it's the similar situation. The person reads a word, but then instead of typing out the translation, they speak it out. So we have an eye voice distance or an ear voice distance, and we can compute all this once this data is processed appropriately from the same kind of an approach. And maybe we can look into this if there's a wish to do this, or otherwise, if people have special wishes, then we can also look into that. In Translog, usually, so the way we have used this often, usually, is to have, as I explained, so they have the translators see the texts, but they are not usually allowed to search for external resources. So the texts were often easy. So I mean it's not very complicated terminology or so, which we would assume that translators would know. And we did not. We told them they were not allowed to use external resources because it would somehow falsify the results. So if we want, I mean, that was at least, I think, one of the reasons. So if we have novice translator, if we want to compare novice translators and expert translators, and we allow them all to look for solutions on the internet, then this would somehow distort this difference between the two groups. That I think was the idea. And so that's why we did not allow translators usually to look up external resources on the internet, but also because keystrokes that are keystrokes are only logged in Translog and also in Trados if they are within this tool. Means So if these keystrokes are, if a translator produces the text and they are recorded, the translation emerges, all this we can record and we have the keystrokes. But if the translator switches the window, goes to a browser, searches for something on the internet, and types in a query there and so on, maybe copies this and pastes this into this Trados or maybe Translog window. So this external resource, external search and so on, that would not be recorded. So inside Trados or inside Translog, because these tools only have access to what happens inside these windows. In order to log also what happens outside, there is another tool that one can use, and we have used InputLog. And InputLog is a tool that was developed by University of Antwerp, I think, and it can be downloaded there. And so this would also run in the background. So one would run then could also run InputLog, and InputLog would log all the keystrokes that are produced on the keyboard. And these could then be merged. So so InputLog does not really know where you are in the text. So assume that you are editing some text in an editor. InputLog does not know where in the text a deletion takes place or in insertions and so on. But Translog and Trados, because they have access to the textual content of the window, they would know, it's possible there to know where in the text a modification takes place. So you have here a trade-off, right? So if you use the keylogger inside these tools, you have access to the text and you can know which parts of the text are changed. But you cannot know when somebody goes outside these tools, Trados or Translog, and type their other stuff. Those tools don't have access there. And InputLog has access to all keystrokes. It runs in the background. It's logged directly to the keyboard. And it doesn't care so much which tool you are using and which window you are, but it logs all the keystrokes. So now one can, if one has these two devices running in parallel concurrently, then we can see which part in input log, in the log of input log, we know which parts were inside this tool and which parts were outside this tool, right? And so there's a small program to merge this and to take this into account so that one can know if a translator goes outside Translog or Trados, for instance, to have all these keystrokes logged also, and then recover from there these activities, what the translator does outside the tool. And we could look into this if you like, and see how we can look into this data. It has not been used very often. Jokke Dams has used this, and she, I think, is also here in this course. I don't know whether she is right now here. Is she? But she is one of the few people who has used this input log in connection with still another acquisition tool, Kasmakat.
Yes, I was wondering if we have difficulty collecting a data set, and especially in my case, I'm hoping to do the key logging, but I know I will not have access to a eye tracking device in the next 2 weeks. Would it be possible to have a data set that, if we kind of all work, well, not all of us, but those of us who do not have our own data, if we were to work on a shared data set, then we could kind of watch over each other's shoulder along the steps of analysis. I was wondering if you were planning to provide a kind of a practice data set.
Yeah, so that's very much the idea. So we have this whole TPR-DB that contains several hundred hours, or several thousand sessions and maybe 100 hours or so of data. And this is accessible to everyone. So yes, so there is plenty of data that we can look into, actually too much. to
Great, thank you.
to look into. Yes.